Everyone, my name is Steve. Thank you so much for attending this particular workshop. My name is Steve. I'm the developer relations lead here in New Relic. What I fundamentally do is I manage the relationship between developers, engineers. I am a conduit or the main glue that glues between product marketing, product engineering, and product success. Again, thank you so much for attending the session. This is a follow-up from the original session that I did not long ago, where I talk about the story of OpenAI, GPT-3, where I talk about tracing. And this session, I'm going to go a bit deeper right here. Again, thank you so much for coming to the session, or you're watching this later on. I'm going to go a bit deeper, especially for engineers, practitioners, underneath the hood, how things are working right there. So today, this is a session about getting started with New Relic for beginners. I assume you don't know anything about New Relic, not really knowing what to do, but also just using Python as an example right here. Again, we do support other languages here in New Relic, but I just want to use Python because it just works very well with my AI app that I have right here. Without further ado, let me move forward and let's start with the session today. So first and foremost, within the session that I did earlier, you saw me actually able to instrument my AI service right there using a specific SDK library that's provided by New Relic. Now, I use that as an example because more and more customers and a lot of engineers are now building more unknown services. They don't know what to expect, especially in the world of containers, Kubernetes, microservices, well, whatever new services that's coming online, like AI. The big question that you want to ask is, how do I ensure uptime and reliability around it? Because building is only one part of the problem. The second part of the problem, that this is where it really gets a lot of headaches for engineers, is how do I actually maintain it up and running? So that's where what you see right here is I use tracing as a way of seeing delays in all the API services that propagate through the service right there. So tracing, it's one of four key telemetries that you see in the world of observability. Observability is a term that's commonly defined, especially in modern reliable practices, where observability is getting closer to why a particular system would fail or succeed at a particular time. That's the principle of observability. And to actually fulfill that, there are four key telemetry that you need to know. One is metrics, the other one is event, the third one is tracing. Tracing is the one that I mentioned earlier, where I want to see traces propagate throughout the whole system. That's tracing. And the fourth one is logs right there. So what we're going to do in this particular talk is we're going to go quite deep, especially on tracing, because given this is a conference on API, it makes a lot of sense to talk about API tracing, how to use distributed tracing, and I'll go a bit deeper on that. And lastly, what we do here in New Relic is we are a full stack observability stack. We help engineers to have full stack visibility throughout your environment, front end, back end, and also we provide you ready to go configuration so that you should see value within the platform right here. So in every good workshop, in every talk, I always like to define my objective really clear up front. What are we learning right here, and what are the key things or messages that you want to take away after this session? First, as mentioned, I don't. If you're very new to New Relic, I'm just going to talk about what is New Relic right here. I'm going to talk about onboarding an agent. There's a lot of things you can do right here, but I'm just going to use Python as an example. Again, it's just an example. There are other agents that you can actually onboard, such as Golang, .NET, Java, or infrastructure agent or front end. And from there, we're going to go with the four golden signals. So this is defined in modern SRE practices. There are four golden signals you need to be aware of. And after that, I'm going to go with distributed tracing. Lastly, I'm going to actually start talking about error inbox. Now, there's a lot of services going to build, and there's a lot of noise. There's a lot of things that you need to be mindful of. But what I'm going to do is I'm going to talk about error inbox. So you actually can quickly identify where the errors is occurring right there. And lastly, as a bonus section, I'm actually going to talk about a bit about AI ops, which Akio actually mentioned in the session earlier. I'm going to talk about our approach in New Relic, how we leverage machine intelligence in helping engineers to diagnose issue much quicker within the environment there. So without further ado, let's go in right here. So what is New Relic? This is probably the architecture diagram I really use to actually speak to my customers right here. Where we can do, where we can't do. This is very clear cut, and actually we tell you right here what type of modules is required that you need in which area you're trying to solve right here. So let me start with the front end right here. With front ends, we have a mobile agent where you embed as part of your SDK compile. where we can collect data such as iOS, Android, application crashes that's occur in the front end, and you actually can correlate to the back end. Front end, we do support browser, even modern browsers such as you see like Vue, Angular, or React.js, which they use common architecture such as single page application. We support that with a very simple JavaScript snippet right there. Next, we also have synthetics. So synthetic is just a very simple ping check where you actually can check the health of your web. It's pretty straightforward. Ping check is usually easy to start, but you can also do things like simple page load, page crawler, scripted browser to do much more advanced things that you can do within your checks here in your Relic to make sure your web's up and running. Second part right here on the back end, we do have APM or application performance monitoring, where we actually look at the performance characteristic that's actually running in your monolithic or microservices architecture. Doesn't matter. We actually support both of them. And in fact, New Relic is quite well known in the industry because our original target audience is always software developers. And software developers are very paranoid and very careful what kind of package they put in your software. For us, our software is actually really light and easy. It's just a set of libraries. Our overhead is really low, which is well known in the industry because we are aware of that. Next, you have infrastructure right here. Infrastructure pretty much it could be on-prem or cloud, doesn't matter. As long as you can put an agent, as long as you can configure integration, where you can correlate data from application with the infrastructure side by side right there. Within also the backend, we do support APM agent, especially for microservices, either written with whatever language that you written right here is supported by us. So here in Asia, pretty common one, JavaScript, Java, .NET, Node.js, Golang. This is the common stack that we see in the region, and we do support them right there. This is one thing that's very unique right here is synthetics. Synthetics is actually also supported, especially for backend microservices right there. So the reason is because synthetics, although New Relic is a pure software as a service offering, we do know that sometimes customers want to do synthetic check for different regions in Asia. Especially for us in Asia, network is often quite an issue. The reason is it could be sometimes rain, sometimes it could be infrastructure, sometimes it could be different country. In fact, for us, which I live in Singapore, network is quite a big problem, especially for us in the region. Therefore, for us, what we do is we give customers the ability to deploy your own Docker container with synthetic checks where you can check whatever you want. It could be a specific island, it could be a specific data center, it could be anything that you have in your environment, but you can actually do synthetic check to make sure that service is up and running. Lastly, everything will flow into New Relic, which is the software as a service platform that we have on the back end. There's really nothing for you to manage. Everything is actually done for you. What you need to do, especially as an engineer, just focus on your application. Get it done. After that, everything is consumed via software as a service right there. Now, this is probably the newer architecture has been coming up for the last 3 to 5 years. More and more, a lot of data that we collect in New Relic is actually not coming from our agents. In fact, it's actually coming from third-party data or open source data. The reason is because with the rise of StatsD, Prometheus, some other third-party software, customers actually want to push data to us. The reason is because they've been using New Relic software. They actually want to correlate. They want to combine everything into one single platform. And what we do here in New Relic is we provide you 4 different telemetry types which you can push into the platform right there. First is metrics. Metrics, it could be as simple as StatsD or Prometheus, or any infrastructure-oriented metric that you see from other platforms. We do give you ability an API to be more specific that you can push data in. Second one is events. Probably the most simplistic form is a JSON format because what JSON format is actually quite commonly accepted within the industry. And just a simple push a JSON format where we contain whatever data you want, and we do accept it in the platform right there. Third one, the third one that you see right here, this is traces. This is where the session will focus predominantly on. When I say traces, sometimes people actually have open tracing formats such as Zipkin or Jaeger. So Zipkin and Jaeger, they are open tracing format that has been around for quite a while, and we do see customers actually instrument it within their application. Sometimes they had enough because tracing itself is very expensive, and I'll talk a bit more why tracing is so expensive. Tracing is expensive because it contains a lot of rich metadata because it actually need to connect from application A, B, C, or you have 10 or 50. That's a lot of compute resources you actually need to do that. But what we do again, we provide customers the ability to push in open tracing data. But however, for the last 2 years, like Akil mentioned in the previous session, there's a rise of open telemetry. If you haven't heard about open telemetry is probably the new open source format that Zipkin, Jaeger has tried to consolidate into one single format that everybody could use. OpenTelemetry is relatively new in the industry. However, it is gaining popularity because people want to have vendor neutral uh, support, but also open source format that's interoperable within application itself. So that's actually tracing. And the third one, right, and the fourth one right here is logs, because we do have our customers actually pushing out to Fluent, like logs from FluentBit, FluentD, Logstash, or open source logging platform. It's just on the push and correlate together, including CloudWatch. We do have the ability and we provide that capability to customers. Again, everything flows into the New Relic platform on the back end, and we give customers the ability to consume those data right there. So today, this particular workshop in this particular this particular session, I'm predominantly going to focus on one area, which is the backend application, my AI application that's written in Python. I'm just only going to focus that. The reason is because there's quite a lot of things that we can do within the New Relic platform, and it's going to overwhelm, especially if you're relatively new to it. With that, let's move forward right here. So first and foremost, what do you need to do to onboard a specific agent? So if you go back to my talk just now, which I thought in API days, where I was able to instrument an application to be more specific, an AI application, and I use tracing as a way to pinpoint exactly which part of the system is not doing very well. Now, right there, why I use AI as an example? Because quite often for us engineers that build software, we're more and more onboarding and building systems that maybe that will not have an integration for. The reason is because if let's say you're an engineer at SpaceX or Tesla, very likely you're going to come to a vendor like New Relic and say, hey, do you have an integration to an AI service? Do you have an integration to Mars or Pluto or the rocket system I'm building right there? Hence, it gives rise to the popular concept that you see right there in modern reliability practice, such as observability. Observability is actually a term that actually made popular in the recent years because of the rise of distributed systems, the rise of a lot of changes within systems. People want to have more confidence and control in instrumenting their services and actually take more control of what they actually want to expose. Observability is also a concept where you want to get closer to why, especially with unknown unknowns. And within itself, tracing, again, what I mentioned in my talk, is one way that people actually use to actually understand which part of the surface is actually really slow. That's actually one of the key tenets in actually improving and building observable systems right there. So with OpenAI, with the AI service that I mentioned earlier, how am I able to profile and instrument that the service I've shown earlier? How I'm able to actually see what's going on automatically and create those traces within distributed tracing? The secret sauce, not just New Relic, pretty much everyone that you speak to, even open source or proprietary enterprise software support, it comes down to bytecode instrumentation. Bytecode instrumentation is actually try to insert a specific program during runtime and actually put some form of lightweight library to actually read those class and functions during runtime. And what we do is we insert, again, it's just like profilers. If you have some experience in performance engineering, and what we do is we profile on the fly. There's one very dangerous thing that you want to be mindful with profilers. Performance engineers love profiling, but profiling in production can be quite a nightmare because it can generate a lot of overhead. Profiling tends to be very good, especially in development environment, but in production, you just need good enough signals to understand where the problem is and triage it. Because when you push things into production, performance really matters. So what happened with what I call bytecode instrumentation is originally started with the world of Java because it's one of the most mature programming language in the world right now. It started from there. After that, that technique slowly got propagated to different type of languages, such as .NET, Python, JavaScript, PHP. The reason it's able to do that is because it's interpreted language, where libraries such as New Relic is able to inject on the fly with those languages like that. However, you need to be mindful of, especially bytecode instrumentation for compiled language, this will not work. The reason is because it compiled to native, and therefore languages such as C, C#, C++, or Golang, or even Rust, bytecode instrumentation is not possible. And therefore, what you need to do with those languages is you need to do manual instrumentation. Now, if you have an interest to do that, just have a chat with us because we do provide you guidance how to do that. In fact, we, especially for Golang, which is very popular here in Asia, we provide you the Golang masterclass, giving you guidance how to instrument a Golang application. So going back again, within New Relic, we have the easy way and the manual way. Like for me, what I'm going to show you in this workshop, I'm going to show you the manual way. The reason is because the easy way, where you actually can attach New Relic instrumentation relatively easy with our step-by-step onboarding guide, it contains a lot of what I call magic stuff to automatically configure a lot of things. However, for engineers, especially for DevOps and SRE engineers, you want to know exactly what's working underneath the hood because at least if something goes wrong, you don't get any sudden surprises. But most importantly, why you want to understand what's going on underneath the hood, the reason is because especially in your CI pipeline, you better know exactly what package you put in because you want to be very efficient right there. So what we're going to do in this workshop, which I'm going to show you later on, which again, try to run a hands-on workshop in a virtual world is very tough. So what I'm going to do, I'm just going to show you because everything is already pre-configured. You as an audience, you can see what I'm working on here. So if you're watching this, especially for people, if you're attending this live session, that's the link available to you. You can actually put your reaction if you can log in the platform if you want to. Try it out. You actually can see if this is working for you. If you're watching this from a recorded session, I'm sorry to say this. This is only available for this event. It will not available after that, so I'm going to delete that right there. So again, for people that's watching this live, you actually can try it out, and as you can see, actually you can log in to the platform by yourself and just play around with it. So let's just get started with telemetry. So as mentioned earlier, so what I'm going to do is I'm going to flick around with my view right here. Is I'm going to look at the application which I actually covered just now in Apidays. If you missed that, don't worry about that. I'm just going to recap very quickly. So what I've talked about in the previous session is the concept of OpenAI GPT-3. It's a democratization of AI service available to you as an API, which you as a developer, as an engineer who build code, you can actually consume those API like Auth0, Stripe, Twillio, and actually can get response based on those services right there. So this is an example which I've showcased earlier in the talk where I talk about Apidays. It generates on the fly by writing a poem, but also when I actually view code, that's just the code that you need to build your service. It's so simple. I think in 2022, this could be a year that we can start really adopting AI service in our application at scale. Or you're an engineer, you aspire to learn something on the side, you want to build stuff, this could be a good time too. So what I did right there is that code that you see here, the end result is something like this, which what I did right here is I just follow the example that's available by OpenAI, and I actually can generate a specific response where I want the AI to help me to name my pet. And I actually can change different point of view. Let's say, give me a name on cat, give me a name on horse, and give me a name on different what I call animals that I have it right there. Now, especially for people who build systems, you ever know that, all right, just building a system is not enough. You need to make sure that system is up and running, especially in production, and especially if it's generating revenue. Uptime, reliability is also the second part of the equation that you need to be mindful of. So the big question that I want to talk about in this particular workshop is, how do I actually figure out where I need to triage and figure out where the problem is? That's where I could use tracing as a way of pinpointing how much time is being spent to actually communicate to those API services on the back end. So with that, what I'm going to do is I'm going to close this just to save some resource. And what I'm going to do is I'm going to show you on the back end what you need to do. So this is a sample code that I have right here, which application instrumentation is relatively different compared to infrastructure or even browser and mobile. Just be mindful of that. Infrastructure instrumentation is probably the easiest because CPU, memory, storage, and network has been around for a really long time. People can create standardization, and API is pretty much consistent for many, many years. However, in programming, in application, it's different because application tend to change, or the framework or the version tend to change sometimes every week or every month. And therefore, every time there's a change, that change will likely break something. And therefore, you need to be mindful of that when you onboard an application instrumentation library. So what I have right here is I import the New Relic agent right here. And after that, I point to a New Relic INI file. The INI file is literally just a configuration file that describes what the agent should and shouldn't be doing. That's pretty much it. That INI file usually resides within the same application folder. It usually resides within the same, especially if you deploy containers or Kubernetes, it just resides within the same application folder. Just be mindful of that and point to that location right there. After that, just your usual API keys. So here's an example of an open API keys. And after that, this is the business logic right there. That's pretty much it. Based on the code that I'm showing you earlier, that's the business logic I use. And of course, you actually get tweak and whatever you see that is appropriate. Now, one thing that I also want to start introducing to you is the concept called observability. Observability is becoming a buzzword right now. The reason is because people are building systems and they don't know what to expect, and there's just too much noise in the system. So what I'm doing right here is enhancing the observation by grabbing the right context from an application and helping this AI to be more observable. What I'm trying to do right here is actually building more observable systems by enhancing and capturing the right metadata that within the application itself. So what I'm doing right here is just with the results that what the AI is generating to me, I'm capturing it. After that, I'm pushing it as a custom parameter. Custom parameter is another way of saying just like capturing variables right there. That's pretty much it. I don't need to deal with span linking. I don't need to deal with parent ID, child ID. I don't need to worry about figuring out what application is connected to what. Distributed tracing in New Relic is done automatically for you. You don't need to worry about that. As mentioned, we want to give engineers just to focus what really matters to them. Once this is done correctly, what you do is if you go into the application, which I've shared you earlier, let me just change my time zone right here. You will start seeing some data that's actually occurring right here. So here, let me just change it again. You can see some data that's actually occurring, and I'll talk a bit more on this red line, but you can see what we're trying to do right here. So within itself, so go back again. Let me just change the time frame just to show a bit more what we're trying to do. Within New Relic, if you're very new to us, what I'm going to show you is just different areas that you can click within the UI. Within New Relic, we suggest that you use Chrome as an example, probably the most recommended browser because of performance and various enhanced features that we can do in Chrome. We suggest you to do that. Once this is done correctly, you're going to see some colors right here. What we're doing the color right here is ultimately we do code level profiling. We profile what's going on in the code, and we use colors as a way of highlighting to you which part or where is it actually causing problem. Within itself, we can see our Python application, the AI part, the business logic part is actually pretty okay. Most of the delay is actually the external service call it's calling out and waiting for a response right there. So you can see right there. And here also you can notice things like application throughput based on my test script that I'm actually running to actually generate some data. I have error rate right here, which is actually quite commonly known that a lot of engineers want to pay attention. But also don't worry on the right-hand side right here. There's a lot of stuff which I'll talk a bit more later on. When you scroll down a bit more, you can see application transaction, where for us in New Relic, our goal is not to bombard you with everything you can see within the platform. Our goal is to show you the one that really matters. Because as I mentioned, what we try to do is help engineers to kind of filter away all the noise and focus the thing that really matters. We focus on the really matters by showing you the most problematic area, which here you can actually straight and jump into it and see the slowest transaction during the time. One thing that we also do here in New Relic is we automatically also can pick up the underlying machine that's running that application. This right here this is my machine running that particular application. We actually picked up the infrastructure metrics underneath it right there. And I scroll down a bit more, I can see additional information such as response time, CPU, memory, and much, much more right there. Again, if you feel like you need more infrastructure data underneath it, we suggest that you install the New Relic infrastructure agent because that's designed for infrastructure. This itself, from an application point of view, it has what I call good enough information that you can actually focus on. Now, once this is done correctly, What you do right here is we can start going into distributed tracing. Right here in tracing, as mentioned earlier, it's a very nice way of pinpointing within a service microservices architecture where the delays actually is. Within itself, what I'm going to do right here is I'm going to go to my tracing tab right here, and you can see a bunch of UI essentially popping up right here. So what I'm going to try to do and what I'm trying to show you right here. For us in New Relic, we kind of follow some of the principle that you see in performance engineering, where you shouldn't just look at problems. Sometimes it's quite beneficial to actually see when things are doing quite well. So what we do right here in New Relic is we capture good traits and bad traits because you want to see when things are problematic, but you also want to see when things are doing very well. It's actually good to have a good even point of view what's going on. So hence what we're doing right here is show you what we call a scatter plot graph to actually see roughly the trace distribution during that time, where it's actually being right there. Now, right here, what I'm gonna do is I'm gonna click this particular trace and let me show you how to read this particular graph right here. So it's gonna expand everything. So what you see here is a waterfall swim lanes, what we call swim lanes that actually indicate all the spans that's going on right there. So what we can see is we actually can see during the call stack which part of the call within the application is relatively slow. So as mentioned, when I click on it, I can see things like response time, throughput, my span duration. If I go to attributes, this is where I have quite a rich amount of data that actually extracted automatically for you, including that custom metadata, which I'm showing you earlier in the code. So you can see it actually captures quite a good amount of details what the application stack underneath it right there. But most importantly, it also helps capture additional relevant contextual data to help the engineer to understand what this trace, the response of what's trying to do. Now, if you remember just now in the code, what I did right there, instead of just capturing pure performance data, I'm enhancing this trace with contextual metadata to help engineers to pinpoint exactly what's going on. Just imagine this. If let's say you capture things like user ID, transaction ID, or some form of ID to indicate during that time what went wrong, it just helps engineers to figure out and just pinpoint exactly where they need to go to. This is actually very powerful. Just imagine if you have microservices across 5, 10, 20, 50 microservices in a distributed architecture, and you start doing things like containers and Kubernetes. This is very, very helpful. Now, so let me just go back right here. So going back again, how do we able to decorate those data? Underneath the hood, we use and we actually follow some of the principle as described with site reliability engineering, or SRE in short. Within SRE principles, there are 4 golden signals that's actually commonly described in the world performance engineering, and we capture those data and we enhance the data within the platform in the UI that you see right there. First is latency. As you've seen earlier with the amount of response time, most people can understand that. Traffic, which is how much your service is demand, and traffic usually is become an issue, especially in production, because every system has some form of limitation what this application can actually operate. Number 3, error rate. This is where applications, especially for engineers, you pay a lot of attention because you just want to understand your failure and success rate for that particular application. And lastly is saturation, or the overall capacity, what the system can and can't do. Saturation is probably arguably the most easiest to understand because most people start with infrastructure monitoring. They say CPU, memory, storage. After that, maybe they look at a CDN or maybe some form of API gateway, how much transaction is you go through, or the limitation what you can go through. These 4 are equally important in understanding what the performance characteristic of your application is. And what we do right here, as mentioned earlier, once you instrument an application, you can actually use what we call out-of-box configuration that's available to you. I'll show you where you actually navigate that. That just helps you to actually kind of quickly configure an environment. This is community-driven. We might not have everything, but I think we have the one for popular technology stack, and this is actually contributed by community itself. And once this is done correctly, what we'll do is we actually auto create some custom dashboard that are available to you, even custom alerts as an initial template for you to get started and up and running relatively quick right there. All right, now let me just go back right here and just show you where do you find what we call New Relic IO. Once I have my application instrumented well, so working quite well right here, I have distributed tracing flowing quite nicely. Now, my next step is I want to create my own custom view. I want to create alerts. You know, is there a much quicker way to do that? And I'm happy to say it is. So what you want to do is you go to instant observability on the top. You can see we start loading a bunch of categories, a selection that's available to you. And what I'm going to do is I'm going to type Flask because my application is written in Python Flask. As you can see, that's one for application for Flask, and I click on it. And you can see what's included right here. And things like dashboards, which I already have one ready to go. I have my alerts, which I'm going to show you later on. And after what I can do is I can say install this quick start. I point to an account, which I'm just going to use one example right here. And after that, it's just going to ask you some questions. Have you installed? Do you want some help? After that, if I say skip it, and I already deploy straight away right there. Just to help you get up and running relatively quick, like things like custom dashboard and alerts so that you actually can expand more on that. Now, once this is done correctly, how does it look like? I'm going to go to New Relic Explorer right here. Again, there's a lot of selections. There's a lot going on right here, but I want to draw your attention, especially on dashboard right here. If I go into it, you can see that application that I selected just now, my out-of-box template is all provisioned quite nicely, ready to go for you right there. If I go to my application Flask, I can see a bunch of applications because I've been generating a lot of test data. So that's why it's actually generating some telemetry. But if you're first time doing this, you might not see any data. Just be mindful of that. But what I can do right here is I actually can move to my mouse here on the top right-hand side. I can click on it. I actually can say, hey, I want to get this as an image. I want to get this as a chart link so that maybe I want to expose this data out to external parties, but I don't want them to have access to New Relic. We do support that. I can straight away create an alert based on that. It's pretty simple. I can duplicate it. I can copy. I can edit. I can do whatever I want. But we also give you the ability to create alert condition based on what I see right here. In fact, if I go back to my page right here, let me just go back to another right here. As you can see right here, this is an example which I show you in the main page. I can do the same thing. I can create an alert condition. I can do the same thing for error rate right here. What we try to do is we want to reduce the amount of clicks and just moving around, just help engineers to quickly get the job done and quickly instrument and go back and focusing what the application should be doing right there. So again, within Flask, what you can see right here is a Flask overview. I can see my error rate right here. You can see a bunch of data that's being generated. I can see my virtual machine metrics is coming from my machine itself, but also it's kind of a key transaction that you can see right here. So this, again, we want to help engineers to have a data-driven conversation. We want to give engineers to have the ability to customize the data wherever you feel that it's appropriate because you know your application way better than us. So again, if you look at the query right here, you can see how we construct that query. Again, the query that you see right here is called New Relic Query Language, or NRQL. It's not a new language or anything. It's just pretty much a SQL language, SQL. If you're an engineer, if you know how to write SQL query, you already know how to do this. That's pretty much it. So we try to reduce the amount of barriers that engineers need to learn, is quickly see value and create the things that really matters to you. All right, so now I've mentioned earlier, with onboarding agent, we start seeing tracing data, we start seeing data stuff, we can now have a dashboard and stuff. Now let's go into distributed tracing. Distributed tracing used to be really, really hard. The reason is because if you're familiar with open source tracing format, that's quite a lot of tedious work you need to do on the code level. Tracing is not a new idea. Tracing has been around for quite a long time, actually, to be very frank. People used to do tracing in the hardware layer, to be more specific, network switches. What people do with network packets is they actually inject the headers in the network packet, they propagate throughout the network switch. The network switch will actually understand, okay, you're coming from where, going to where. However, with the rise of cloud, with the rise of hybrid environment, you're not able to do that already in the network switch layer. So what people do right here is now people do it in the application layer. Again, this idea originally came from Google. There was a white paper that's written called Project Dapper, and they actually shared to the world how they do tracing on the application layer. This is where different vendor really start to differentiate ourselves. And what they do is what they do around tracing. First in New Relic is we do support with tracing out of box. You don't really need to do about headers, parent ID, child ID, or anything. It's done automatically through the agent. but also it's supported with different languages that you have in the environment. It could be a Ruby, Java, Python, Node, all intermingled together, doesn't matter because it's all done automatically and we fuse them quite nicely with the platform. Now, as mentioned earlier, with the rise of distributed architecture, tracing is becoming a really key component in instrumenting and figuring out the unknown unknowns. And also this give rise, as I mentioned earlier, to the concept of observability. And going back into given this is API days, where everything is API driven, tracing is a valuable tool in figuring out within your API where the performance bottleneck is. Underneath the hood, how tracing really works is usually have what we call the main parent trace or the main trace that's coming, let's say, from the front end, or the application is generating that. And within asynchronous concurrent operation, you have child span that's being generated to go do different things. Now, within code itself, if you do this in open source, you have to actually link them. This is the parent span, this is the child span, this is the ID, and kind of like fuse them together into one single master ID on the top within the trace root, and you have the one single ID. This itself, unless you're an instrumentation engineer, it can be quite tedious. It can spend a lot of time, but however, this is usually what people do right there. For us, what we do is we actually inject our own headers, the New Relic header, to understand where you're coming, and we do distributed tracing automatically. Once this is done correctly, we actually just start mapping up a map. So here's an example of probably a more complex architecture. We can see this is coming to here it's coming to there, as I make external call. And what we can do is we can start creating what we call a trace map. A trace map is a visualization, what's going on in the environment, and you can pinpoint exactly where the issue is. Now, going back again, what I did with my AI right there is I used tracing as an example and a very valuable tool in figuring out, is it OpenAI or Twillio that's having a problem? Within Solve, what I did right there is I'm improving the context of my trace data by using custom attributes. What I'm trying to do is I'm trying to build observable systems. When I do tracing in production or in staging or in development, I want to understand what's going on in that trace, and I want to capture the data that's really meaningful instead of just performance characteristics. So here's an example that you've seen earlier. I'm using Twillio WhatsApp to be more specific. And what you can see right here is the trace data, including the metadata that's actually respond, and you can see that's being captured within distributed tracing within the platform right there. Lastly, the big question that people always love to ask me is, do you capture database query? Of course we do. The reason is because we also look at the database driver that the application is actually going through, and we actually capture that query, but we mask it in the right way so that you don't get into trouble. The reason is because if we capture the full database query, both of us going to get into trouble. Because for us being a software as a service platform, we need to be mindful of security and compliance. But what we do is we give you hints, that's the query that's causing problems. There's one more step that we do here in New Relic is we actually do performance anomaly detection. So when you actually create, just look at a specific trace, we will tell you and say, hey, I think there's a performance problem right there, and you need to be mindful of because we never seen that in other traces. So therefore, as I mentioned, helping the engineers to figure out what's going on in the environment right there. Now, I talk about a lot about tracing, but ultimately, a lot of engineers always want to look at errors right there. Now, within itself, what we do is we have this concept called error inbox to actually harvest all the errors that's actually generating of an application itself. And the best way to actually show you this on error inbox is actually just to show you how does it look like. Now, if I go back into my application right here, if I go to name my pets, and I'm going to go into a specific time, I'm going to show you from scratch how I did it. What I did right here is I did generate some test data. That test data breached the alerts that I've created earlier, erased an alert because of some errors right there. What I'm going to do is I'm going to scope the area that I want to focus right there. And you can see the alert that's being generated right here. The alert is being generated because I was seeing really, really high error alerts. Now, right here itself, there's a lot of things you need to look after, right? As an engineer, there's a lot of noise. I just want to focus on things that really matters. So what I can suggest to you is once an application starts to have an issue, you can actually use error inbox just to narrow down a bit more where you really need to focus. So here's an example that I did with my application. I have some errors that's being generated from my application right there. So what I did right here is I go to name errors. I can see the error that we captured from the application itself, and we tell you all the information around it right there. And this is the really cool part. What we do right here is we harvest the stack trace that was generated from the application. Again, only if the application generates a stack trace. Not every error will generate a stack trace. But if that application does generate a stack trace, and I'll show you the example, we'll pinpoint to you exactly where the error is. Within Cell, we also have feature attributes you can see right there, just to enhance that metadata, to enhance that observation that you see here. We include attributes, but also additional collaboration information if you want to do that, because sometimes we do have engineers that want to collaborate to solve this particular issue. We did build in collaboration feature to allow engineers to collaborate to solve that problem right there. So again, error inbox is pretty cool. It is linked directly to the error that I've shown you earlier. And it's a very nice way just to focus and narrow down. And sometimes we have customers just to create error observation based on what they see right there. Now I have around 7 more minutes to go, just to wrap up nicely so that I give you time to actually do other things in life. But what I'm gonna do is I'm gonna wrap it up with applied intelligence. If you remember just now, I talked about with Akil asked about this question about AI ops, artificial intelligence assisted for operations. What we do right here in New Relic, we believe AI as applied intelligence, where we're using machine intelligence and apply it to a specific incident right there. First, we have a different point of view with AI ops. When AI ops first came out, it promised the sky and the heaven. It kind of oversold what it's trying to do, and in the end, a lot of people got disappointed too. We learned our lesson too, because when we first launched AI Ops, it didn't go very well. And what we're doing right here is we want to mimic what real world is doing, and we found much more success right there. And let me show you what we do right here. So I like to use the word or the story that I discussed with Akil is engineers like technology, but we're also very skeptical at the same time. I use the Netflix as an example because when you first log in on Netflix, Netflix doesn't know what you're trying to do, and it doesn't know your taste and preference. And what it first was trying to do is provide you a recommendation saying that, hey, maybe we'll suggest you should do this. We should suggest you should do that. And over time, it starts to build a profile to you, but ultimately you have to decide. Again, just like Google. Google can tell you roughly the top 10 restaurants, but you have to decide. Us engineers, ultimately, we're very skeptical. We don't want to feel like we're being told what the machine should tell us to do, but at least we want to have some guidance and assisted analysis where the problem is. So what we do right here is we choose the word AI not to be artificial, but apply that intelligence into as part of the investigation workflow. If you remember earlier, I talked about distributed tracing, about anomaly trace that we do automatically for you. That is a classic example. What we're trying to do here is, as part of your investigation, we want to highlight to you there's some odd behavior that's occurring in the environment right there. That's how we see implied intelligence being applied in operations, uptime, and reliability. Underneath the hood, how we do it right there is we actually capture data underneath it. We detect issues that's occurring in real time. What we do is our backend will start diagnose and start to event correlation just to narrow down the blast impact of that radius, so that as an engineer, you kind of narrow down instead what you want to do right there. One fundamental difference that we do a bit different compared to what other providers are doing is we give engineers the ability to train the model over time. Just because our model will work for e-commerce vendor, it's not going to work for a manufacturing customer. What the data that's going to work for a manufacturing customer will not work for banking. We understand that, and we give you the ability to train your own model when you actually do onboard New Relic in the platform right there. And the best way to show you this is going back into the platform right here. If I go back into the environment, you can see we already start detecting anomalies right here, as I've shown you earlier. When you click into it, we actually highlight to you, hey, we did notice something's very odd. There's a lot of errors that's occurring right now. And what we do is again, event correlation. We narrow down right here. So you actually can investigate. It's related to error rate. And that's the link that points you to the previous UI, which I've shown you earlier. So that helps you to narrow down a bit more so that you don't get over flooded by noise and a lot of unnecessary information right there. Also, as mentioned, collaboration, you actually can add into it, but also, as mentioned early, ability to train the platform. If you see on the right-hand side right here, do you want us to detect anomaly like this? Is this good or bad? You decide. As mentioned, every environment is different. Every customer is different. We want to give you the ability to do that right there. Now, also, as mentioned early, if you notice right here, there's a lot of intelligence that we hear on the right-hand side, just to help you to do that. But just to wrap it up, my session right here, I did mention about the Netflix recommendation model right there. If I scroll down a bit more, what we can do here is I'll just go into another application right here to see if I can do that. So what we do right here is if I go to another application, I'm going to just change this. What I'm going to do is I'm going to go into apply intelligence. What I'm going to do is I'm going to go to incidents right here. It's, as mentioned, when an incident is being triggered, we want to do some smart correlation just to narrow down. And you can see right here, when I click here, you can see it brings up into the same view, and you can see all the correlations done nicely for you in an analysis tab. We'll look for attributes, either out-of-box attributes that's being collected on your behalf, even custom attributes, custom data that you capture with your platform. We used to do that analysis for you, and we narrow down quite nicely to help you triage issues much quicker. With that, I think I covered a lot today, but also my time limitation that I have in this talk. What I'm going to do is I'm going to recap what I did to instrument my AI service. First, I find a supported language that I can use within my library. Because this is an AI, very, very likely I'm going to see everything. I have to use observability principles to enhance the system that I have it right there. I attach the instrumentation library like what I've shown you earlier, and I can start creating alerts, which I showed you earlier. So as you can see in the previous walkthrough, what I did is I actually created some workload to generate some error, which raise an alert, and I can use a combination of tools and modules that I have, like distributed tracing, error inbox, and alert correlation, just to narrow down very nicely where do I need to focus as an engineer. My goal is to help engineers to quickly figure out what's the problem so they can focus on their application right there. In short, just to summarize right here, if you're interested to try out New Relic, what you can do is you actually can go to our New Relic sign up page. We have a free forever account. Yes, free forever, not free for production, but free good enough for you to try it out, where you need to, how you want to instrument your app. And what you can do right here is just follow the steps, select a data center. After that, just get the email and you can start instrumenting your app and pushing that data forever. Again, that free with a limitation of 100 gigs of data. That's a lot, and some users can actually play around, and from that, you can actually try it out right there within New Relic. Again, my name is Steve. If you just want to add me or just connect with me in LinkedIn, just look for my name, New Relic, Steve at New Relic with my face. If you see this one right here, that's the right guy. And again, if you have any question, just feel free to reach out to us. All right. With that, thank you so much. If you have any question, I'll be around just to answer any technical questions before I log off right there.